Hello everyone, so this video is going to help you review how to graph when quadratic equations are in standard form. So we're going to start off with reviewing what an equation looks like when it's a standard form. And it's, as you can see it here, ax squared plus bx plus c. Your a will be a number, your b will be a number, and your c will be a number. And they play different roles in when you're graphing. So we're going to do that first thing with our equation. Let's go ahead and identify what A, what B, and C are in your equation because eventually we're going to be using those values. So A is 1 because there's no number in front of the x squared. B will be the number in front of the x, which is -2, and C will be our last term, which is 2. So the first step we'll do is we're going to find the vertex. Now, I've broken down the process of finding the vertex into 2 steps. So the first one, we're just going to focus on finding the x-coordinate, which is using that formula there. So the top is negative b. So I know that our b is already negative, but you have to include the original negative sign that it came with. So on top, because you end up with the situation where you have a double negative, that turns into positive, so we get +2 on top, and 2 times 1 is 2. So if you simplify that, you get 1. So that means that your x-coordinate for your vertex will be +1. Now, once you know your x-coordinate, you simply replace x with +1 everywhere you see it in your equation, which is in 2 places. So we'll be plugging in 1 into the inside of the parentheses. And then we'll follow PEMDAS to know what order in which we're going to be simplifying this expression here, this equation here. So the first thing we'll do is take care of the exponents. 1 squared means that you're multiplying 1 2 times. 1 times 1 is +1. So 1 squared becomes +1. Then since 2 and the 1 are together, we're going to multiply them and we get -2, bring down the +2 there. One way you can check if you're doing this correctly is by checking if the first number, which in this case is 1, is half of the second number. And 1 is half of 2, so that means we're doing this correctly. We're going to subtract first because PEMDAS says to do addition and subtraction from left to right. You get -1, and then you add -1 plus 2, and you get +1. So now you found your x-coordinate of your vertex. So your vertex, which is a point, is going to be 1, 1. The second part is identifying if your parabola opens up or down. And we know that our A tells us that. And our A in this problem is +1. Since A is +1, that means that your parabola will open up. Since A is positive. So anytime you have a positive value for A, your parabola will open up. It will look like a U, and your vertex will be the lowest point. C helps us identify our y-intercept. So your y-intercept in this case is going to be whatever C is. So since C is 2, then your y-intercept is 0, 2. Every time you have a y-intercept, your x-coordinate is always 0. That's where we got the 0 from. So now you have 2 points that you can graph for your parabola, your vertex and your y-intercept, which is enough to graph your parabola because we'll get a third point by using the line of symmetry. So let me just write here what our vertex was. It was 1, 1, and our y-intercept, which is 0, 2. And we'll go ahead and plot those on the graph now. You always start at your x-axis, and since your y is 1, we went up 1. And then we'll graph our y-intercept, which is at 2, so it crosses the y-axis at 2. And we'll use the line of symmetry, which is a vertical line that goes straight through the vertex. But let's sketch the left side of the parabola right now. So, like I said, we're going to use that line of symmetry, that axis of symmetry that splits the parabola in half. So since we have a point on the left that's 2 squares to the left, then we have the same situation on the right, since that line is splitting the parabola into half. Now we have a point on the right, we can sketch the right side of the graph. It's going to look a little funny because how the graph is scaled, but there's your parabola. And we can erase the axis of symmetry because that's not really part of the parabola. We just use it to get other points. And that's how you graph quadratics when they're in standard form. I hope the video was helpful.